Hi, welcome back to the Science Fair series. Today we're talking about data handling in part one. This one's part one is called Central Tendency and Variation. So the science project is really a story told through your data. So an inquiry project, the data is used to validate the hypothesis. In an engineering design project, the data is used to validate that the project meets the requirement, for example, speed or weight or whatever the improvement is on your project, in your engineering design. But let's start with something everybody understands, darts and targets. So what is precision? Precision is a repeatable result. So if you're throwing darts and you're getting them all in the same place over and over again, that is called precise. It's repeatable, can get close to the same result every time. But notice it's not in the center. So that means it's not accurate. Accuracy is when you get close to the desired result over and over to the target. This is called accuracy. But you might notice that it's kind of spread apart. It's not very precise. So here is precise and accurate, where you're getting you're getting the desired result. So the most common way to describe data in a data set or in a data set for a project is by using the measures of central tendency and variation. What does that mean? Well, let's learn about data a little bit. The central tendency is a way of finding the center of data using the mean, the median, and the mode. The mean is the average of the data, the sum divided by the number of values. The median is if the group of values in your data set are placed in order from smallest to largest, the center value is the median. And the mode is if a number occurs more than once in a data set, or the one that occurs the most in the data set is the mode. So let's start with the data set. So say I have my target here, and from the center to the first line is 0 to 1. From this circle to this circle is 1 to 2, 2 to 3, 3 to 4, 4 to 5. And then I have my circles around here that this one's like 3.1, 3.2, 3.3, and then here's a 4.1, right? So this is my set of data values from throwing my darts. Okay, I gave them a value, I got them a value. Now, the median of my data set is 3.7. I have them in order. I have 4 above, 4 below. The median one is 3.7. The mode is the one that shows up the most. And this one, 3.7, shows up the most. So the mode is 3.7. And the mean, or the average, is the sum of all of them divided by the number of data points. And then you get your mean, or your average, 3.6. Okay, so that means the central tendency of my data is defined as the middle of my data set, which is mean 3.6, median 3.7, mode 3.7. So I've described the central tendency of my data set. So, but variation is another way of describing it, right? So this is where we go back to the accuracy or the precision, or right, how close you are to repeatable every time. And that's important in a data set, because if you can get the same result over and over again, then that means that you are very certain that what you're doing is your hypothesis is proven, it's repeatable. Right? You're getting close to the same results every time. So a variation is a way of describing the span of your data. Is all the data values close? Is it repeatable? Or are they different values and vary? So we're all familiar with the bell curve. You know, there's a grades is a good way of describing the bell curve, right? So everybody is the average is C, right? And then as you move up, you get the B's and the A's and the A pluses, right? Same with not doing so well, right? The D's and whatever. Or another one is speed, how long it takes you to run, let's say, the 20-yard dash, right? So, everybody has sort of an average speed. Then there's the ones that are really fast and the ones that are really slow. And the ones that are really fast are fewer. And everybody kind of works around the same number or gets closer to the same number in the center. This is called the standard variation, average. And if you have a precise result, right, so that lots of them are in the same area, then your bell curve is going to be very narrow. And if you have a more spread out result, then your bell curve is going to be more elongated, right? And why is this? Well, it's because we're trying to describe the data how everybody is relative to the center, right? So we have calculated what our center is. So how far away is everybody from the center? So like 4.1 is farther away than 3.7. So what we're doing is we're calculating the span, right? So you can almost kind of see the bell curve here, right? The really tall, small ones, and then the average that gets kind of high, right? So the standard deviation is what is the term is used most frequently as the way to measure variation. A standard deviation is where 68% or 2/3 of the data resides from the mean. So that means here's our mean, right? Our average, right? And if you make a square around 2/3 of the data, this is called one standard deviation, right? So it's a measure of how narrow or elongated your data set is, okay? Actually, the calculation of standard deviation is pretty complex, but you can use Excel. So we'll go to Excel, and in order to use Excel, you select the square where you want to put the standard deviation. Here's the instructions. You select the function tab, go to insert function, select it, and I'll go show you this right here. Okay. So here we are in Excel, right? And say I want to, let me clear these out. Okay, so here I want to calculate the mean, the median, and the mode, and the standard deviation of my data set. So I say, okay, I want to put my mean right here. So I'll go to formulas up here in the Excel, right? Normally I'm at home, but if I go to formulas, I can go to insert function. And let's say I'm going to do, what am I going to do first? The mean. So I'll type in average, average, okay? And I'll select average and hit okay. And then it'll say, okay, I'll click the average. What data, what numbers do you want to use? And I'll just go highlight them, right? So I can go highlight my value set and let go, hit okay. And there, it calculated my average. Now, just to show you, just for quick, you know, if you go to format here, you can set how many decimal points you want. And I like one, right? Especially when I just have one here, I should have one here. But you could, you know, just change your decimal values right here. Okay. So now if I wanted to do the median, I can go to select where I want to put it, go back up here to formulas, go here to insert function, and now I'm going to type median, right? M-E-D-I-A-N. Okay. And it comes up, I hit go, right? It selects median. I hit OK. It says, what data do you want to use? I'll use my data set and I'll hit OK. I can do the same thing with mode, right? Insert function, type mode, hit go. It finds mode for me. I say I'm going to use mode. What data do you want to use? And I'll just go highlight it. Okay, hit OK. There's my mean, median, mode, just like we had calculated before. Now for the standard deviation, I can do the same, right? Insert function. And standard deviation is actually a pretty complex, so you don't have to know how to calculate. Like, I mean, we know how to calculate the average. You sum them up and you divide it by the numbers, but the deviation is actually a pretty complex thing, right? It figures out the differences, it squares them, it averages them, right? So now it's going to say, okay, there's my standard deviation, 3.7. Whoops, is that right? Insert function. Make sure. Insert function, standard deviation. Okay. And I go select all my values and I hit OK. Yeah, that's better. I don't know what I did wrong there. Okay, so here's my standard deviation. That's the number I expected. They're actually pretty close together, so my standard deviation is very low. Okay. So, but what does all that means? Okay, so now we know how to create our mean median mode and how to describe our standard deviation, and we'll work more on what the standard deviations mean and how these are all related in the next one when we're talking about skew and common cause. But let's go back to our slideshow here, and we'll go to talk about. So here's some examples of central tendency and variation. Right, so I've gone through and just made a couple different sets of series, just to look at what the data looks like when I create the mean median mode. So you can do this by just, um, you know, creating the mode here, right? The average of these right here, and then if you wanted to have more charts, you can just move it aside. So if I wanted to have another series right here, just so I could play with numbers, I would just grab these right here and scoot them over, and it's going to have put the values right there. Okay. So what does this mean? So let's look at series 1. I have them, all the values are 8. So of course my mean will be 8. My mode will be 8. My median is 8. My minimum maximum 8. My standard deviation 0. I have no deviation from the center. Okay. So you can kind of see that. So now I have series 2 where I've put an equal number of 7s as I've put in 9s, right? So it says, okay, the mean is 8, and that makes sense because they're equal number of 8s. I've averaged them together. The median is 8 still, right? Because there's my median. I have them in order. And my mode is 8 because I have more 8s than anything else here. Okay, minimum, maximum, and my standard deviation is 0.08, or it's 0.8, sorry. And that's because I have a span now. I have from 7 to 9. So let's go to another series just for another example. So now I've gone to where I have 4 4s, 4 6s, 4 8s, 4 10s, and 4 12s. My mean, my average is still 8 because they're balanced, it's balanced. My median is still 8 because I have them in order and it's balanced, right? My mode, it shows 4, but it's because I have no value that more than the than it is. And so if I changed one of these to 8, then my uh, oops, 68. Change that to 8, right? So now my mode is also 8 because I have more 8s than anything else. And notice my deviation's gotten bigger because I'm farther apart, right? I'm 4s. So now I'm going to change it so I have 0s and 16s. And the same kind of thing, right? My standard deviation is bigger because my span, all of this, it gets farther and further away from my center. So that means my span is bigger, my standard deviation is bigger. Same with this one, right? Where I have uh, more 16s, right? You can see that I have more 16s this time than 14s. So my span is bigger, right? I have more on the outside circles than on the inside. So, and here's some more interesting numbers. So here I don't have I have more smaller numbers, right? So my median is kind of high, but I have lots of small numbers, right? I don't have the nice 8, 7, 6 like I do before, right? A bunch of small numbers, and then lots of high numbers, but they're spread out, 16, 14, right? So you can see my standard deviation went higher, my maximum, minimum, right? Mode is 2 because, again, because I have the same number of values everywhere, right? More 2s than anything. Oh, no, I have more 2s than anything else, right? And then, but my median is still 8, right? Because the average of all this, right? So this is where you're starting to see where the average doesn't really describe the data, right? Because I have half of my data is 4 and below. So that's why we need to talk more about these other ways of looking at the data. And the same thing is true here, right? So this one I have all 2s all the way up to here. My average is still 8, so it doesn't describe my data very well. Median is 2, mode is 2, right? And max, right? But you can see that I'm starting to get higher and higher variation, or higher and higher standard deviation. Okay, So, and then you can just kind of play with data. So like I said, just grab this, right? This is, all I did was I put the average there, I put the median there, mode, minimum, maximum, variation, right? You don't need to worry about variation, standard deviation, STD, right? And then you can just go change numbers. So you can go grab a data set, right? Copy it, paste it, and just play with numbers for a while. See if you can get used to or get familiar with what makes these change, right? So if I make them all 16, right? Right, so I made them all 16 all the way up to here, and then I just have a couple twos, right? So my mean, my average, my median is 16, it's my maximum number, right? So it doesn't describe my mode, it's 16 doesn't describe it. My average 13 doesn't really describe it, right? Because I have a whole lot of 13s, but I have a big span, right? A lot of these away from the center, right? Here's 13. All of these 13 to 2 is a big difference. So grab an Excel sheet, play with data, and learn a little bit about mean, median, mode, and standard deviation, and see if you can get a good glimpse of it. And then we'll talk about skew next. And we'll talk to you then. Bye now.